Today's lesson is 6.4 on addition and subtraction with unlike denominators. Last time in class we were working with fractions or rational expressions that had denominators that already match. So the difference today is that we're going to need to get our denominators to match. And this can be a little different for each fraction depending on the fraction. And these are easy enough that we can do them by inspection. You can pretty much look at the numbers and say, well, this is what it goes into. 4 and 5, our common denominator is going to be 20. And we get that by multiplying the top and bottom of the second fraction by the denominator of the first, and by multiplying the top and bottom of the first fraction by the denominator of the second. When we do this multiplication, top times top, bottom times bottom, we get 15 twentieths plus 8 twentieths, which gives us 23 twentieths. If we could reduce that, we would, but these have no factors in common. And in algebra, we don't want to change this into a mixed number. So that's how we leave our answer. Moving on to the second problem, I don't need to multiply 4 times 14 to get a common denominator. These both share a factor of 2. 4 is 2 times 2, and 14 is 2 times 7. So I see that what these both go into is 28. 14 gives us 28 if we multiply by 2, and 4 gives us 28 if we multiply by 7. And the way I'm thinking of that is this has two factors of 2. This has 2 times 7. So the least common denominator will have 2 times 2 times 7, which is 28. So moving forward and doing our multiplication, we get 7 times 3 is 21, over 7 times 4 is 28, our LCD. For the second fraction, we get 2 over 28, and then we do the addition, adding the top and keeping the bottom. Again, we want to think about whether or not we can reduce. In this case, we can't reduce, so we leave it as it is. There are no common factors other than 1 between 23 and 28. Moving on to this last example, I notice that one of the denominators actually goes into the other one. So I don't need to change both fractions here. If I simply multiply the first fraction by 2 over 2, we'll have a denominator of 8 for both of our fractions. So this first part becomes 6/8. The second part remains 7/8. And when we do that addition, we get 13/8 as a result. So that's the basic idea that's behind what we're going to be doing today. But we're going to be looking at fractions that involve variables or even large polynomials, binomials or trinomials. So let's see what those look like. So our next example is going to be n over 6 plus 2/3. We're adding fractions, but the denominators don't match. In this case, 3 will go into 6. So our least common denominator is going to be 6. In order to get that, I multiply by 2 over 2. This gives us n over 6 plus 4/6. And just as we've always done, we add or subtract on top, whatever this tells us to do, and we keep our denominator the same, n plus 4 over 6. Don't be tempted to try to reduce or cancel with the 4 and the 6, even though they're both even, because 4 is not a factor, it's an addend, and you may not cancel or reduce using addends. One piece of advice I would give you as you watch these videos is that you can always pause it. And you can always go back as well. So what you might want to do when I put a problem up is pause the video, try to do it on your own first, or at least one step, Watch a little more, pause again, see if you can take that next step on your own. That will help you to be more engaged with the process and help you to make the learning a little bit more your own. So notice again here, we only had to change one of the denominators. We did that by multiplying the top and the bottom of a fraction by the same thing, which is equivalent to multiplying by 1. So we haven't changed the value. So moving on to our next example, we have 6 over m minus 3, and we're going to add that to 8 over m plus 8. Now, I don't see anything that both of these denominators, that will go into both of these denominators. For instance, I can't multiply this one by anything at all reasonable to turn it into this, and vice versa. So here, this is going to be like our very first example where we had 3/4 and 2/5. I'm just going to have to multiply the top and the bottom of each fraction by the denominator of the other fraction. So our LCD is going to be m plus 8 times m minus 3. So as we move on to our next step, I will go ahead and do this multiplication. I'm going to distribute in each case. So our first fraction becomes 6m plus 48 over our common denominator of m plus 8 times m minus 3. And our second fraction becomes 8m minus 24 over m plus 8 times m minus 3. I wouldn't multiply the bottoms through the denominators because when we get done, we want to see if anything is going to cancel. So I'm going to leave these in factored form. And what remains now is that we need to add the numerators. So let's do that. 6m plus 8m is 14m. 48 minus 24 is going to be plus 24. And then we still have our common denominator. Now, I want to think about this to see if I can possibly reduce it. I notice I could pull a 2 out from the top. But if I did, I'm just going to think through that out loud up here. That would leave me with 7m plus 12. And that doesn't cancel with anything on the bottom. It doesn't match anything on the bottom. So I'm going to leave my answer as is. And that is the final result for this problem. We have 3 more examples. I should remove the word basics because we're not doing basics anymore. Those were our first 3 fractions, and this is becoming far from basic. The next one is kind of a special case that shows up every once in a while. Let's do 9 over 8 minus y, and we're going to do plus 8 over y minus 8. Now those denominators almost look like they're the same thing already. They both have a y and an 8 and a minus. But it makes a big difference. Remember, subtraction is not commutative. And you can check to see that these aren't the same by maybe plugging in a 10 for y. 10 minus 8 is positive 2. But 8 minus 10 is negative 2. These things actually have opposite values. And we looked at this a little bit in an earlier section. But one of the ways we could deal with this, the way that I think is probably easiest, is to multiply the top and the bottom of the fractions, and it doesn't matter which one. Multiply the top and the bottom of one of your fractions by a -1. Because what that's going to do is flip the signs. So this first rational expression now becomes -9 over -8 plus y once we multiply this through. The second fraction remains the same. Now our denominators match. They might not look like they match because they're in a different order, but we can rewrite that. we could say, hey, this is addition. Let's use our commutative property and switch the order. This is y plus negative 8, which is the same as y minus 8. Oh, well now the denominators totally match. We can add what's on top. We get negative 1 over y minus 8, and that's our final result here. So just remember, sometimes your denominators may look very much alike, but they're actually complete opposites. And the way to handle that is to multiply top and bottom by negative 1. So 2 more examples of increasing difficulty. So fasten your seatbelts. But also, like I said, what you might want to do is pause the video and see if you can take the first step on your own to try to judge where you're at. So this next one is negative 6 over y squared minus 4 minus 3 over 2y plus 4. Again, we have a situation where we can't just eyeball it this time and see what our common denominator is. In this case, what we want to do is to factor both of these to see what factors we're talking about. I did this with our basic examples, the second one where I had a 14 and a 4, and I broke it into 2 times 2 and 2 times 7. That's what I'm doing here. I'm breaking these apart to see what factors are a part of them. Well, oh, and I made a mistake. Did you catch me on that? It's about y plus 2, because 2 times 2 is 4, right? So that's what we want. I see 3 different factors: y minus 2, y plus 2, and a 2 all by itself. So I'm going to make a note that our LCD contains the factors 2 and y plus 2 and y minus 2, because I can turn this denominator into our LCD just by multiplying by y minus 2. And I can turn this denominator into our LCD just by multiplying by a 2. So both of these go into that. And that's what we're concerned with when we're looking for a common denominator. So I'm going to multiply the top and the bottom by what's missing from each one of these. This is missing a 2 in comparison to the LCD. So multiply the top and the bottom by 2. This is missing a y minus 2. So multiply the top and the bottom by the same thing, just like you always do when working with fractions. Now it's kind of a mess, but let's pull it together here. 2 times negative 6 is negative 12. This is over our common denominator. Back here, I will be distributing. And we have a minus in the middle. Don't forget that. It's an important detail. And then we have our common denominator on the bottom. And 2 steps remain. We need to do the subtraction of the numerators, keeping the denominators, and then we need to see if we can reduce. So let's check that out. This becomes, by the way, be careful, that's a minus. We've got a minus here. Don't lose track of these things. When I combine the top, it's going to be 3y. I have a negative 12 minus 6, or negative 12 plus 6, which is going to give us minus 6, right? Negative 12, positive 6 gives us minus 6. We keep our common denominator. But then, once again, we need to look and say, well, can I factor this? Can I do some canceling? In this case, we can. If you pull a 3 out of the top, notice that you have a y minus 2 that matches this y minus 2. And those will cancel. So your final answer is 3 over 2 times y plus 2. That's the final result. So always do some factoring up top to see if you might be able to reduce. Okay. We have one final problem. This is our grand finale. It's really, really big. Again, remember your pause button. If you feel like this is going too fast and you didn't have enough time, pause and look at the step. And so that'll slow it down for you. Our last one, the grand finale. We have 6 over k squared plus 3k minus 1 over k squared minus k plus 2 over k squared plus 2k minus 3. So that's our last problem that we're going to work on. Once again, I'm going to factor each one of these and take a look. Just as I could factor a k out here, I can factor out a k here. And I'm really hoping that this trinomial breaks down to be k minus 1 times k plus 3. This doesn't always happen, but your textbook is a setup. The authors have written your textbook in such a way that things should work out kind of reasonably. And guess what? If you factor this, in fact, you do get a k plus 3 times a k minus 1. And if we take a look at this, the factors that we have are k, and k plus 3, and k minus 1. I don't see anything else that's a different factor. So the LCD that we want is k times k plus 3 times k minus 1. So again, I'm going to multiply each fraction or each rational expression by the factor that it's missing. So here we go. This one needs a k minus 1. And I need to multiply it top and bottom. This one needs a k plus 3. So I'm going to multiply that top and bottom. This one needs to get multiplied by k. And now we are ready to rock and roll. So I'm going to erase this to make some space, but you see this under each fraction. It's been written there. So let's go ahead and distribute. So the top of the first fraction becomes 6k minus 6 over the LCD. Minus, 1 times anything is just itself, over that common denominator again. Order doesn't matter. We have distributive or commutative property. And this is already ready for us. Now, we have common denominators all the way through. We're going to combine the numerators. The thing to watch out for is that you have this minus, so be careful. 6k minus k is 5k, plus 2k is 7k. I just gathered up all of the like terms, remembering that this one was being subtracted. Now I'm going to move on to the integers. I have minus 6, and I'm subtracting 3 from it. So that's minus 9. This goes over our common denominator. I see that the top can't be factored, so I know I can't reduce this. So that is our answer. And that's the end of the lesson on 6.4, addition and subtraction with unlike denominators.